My dear students, welcome to Karnataka Learning Management System. Myself Suguna HG, Assistant Professor, GFGC and PG Center, Chintamani, Chikkaballapur District. In this video, I am presenting you BSc Mathematics Paper 2, Session 32, Problems on Asymptotes. Here we are going to find the asymptotes for Cartesian and polar curves, and also we are discussing the working rule to find the asymptotes. First, let us know the working rule to find asymptotes for Cartesian curves. Let f of xy is equal to 0 be an nth degree equation representing the Cartesian curve. Step 1. Arrange the terms in LHS into groups of homogeneous expressions of the same degree of the form hn plus hn minus 1 plus hn minus 2 plus so on is equal to 0. That means we have to arrange the terms of the equation in the decreasing order of their degree. Step 2. After arranging them in this form, put x is equal to 1 and y is equal to m to get the equation phi n of m plus phi n minus 1 of m plus phi n minus 2 of m plus so on is equal to 0. Then solve this equation by equating the highest degree term, that is phi n of m to 0, to get the slopes of the asymptotes. Slopes means they are nothing but the roots. Let them be as m1, m2, so on. Then use the formula c is equal to minus of phi n minus 1 m by phi n's derivative of m for non-repeated roots of m, which gives the intercept c1, c2. Then the asymptotes corresponding to them are y is equal to m1x plus c1 and y is equal to m2x plus c2, etc. we'll get. Then for repeated roots, if the root is repeated twice, then we have to use the formula c square by 2 phi n double derivative of m plus c phi dash of n minus 1 of m plus phi n minus 2 of m is equal to 0. See, the total number of asymptotes will be equal to the degree of the curve. So it never exceeds the degree of the curve. Then we will take few problems and let us work out according to these steps. First question. Find the asymptotes of the curve 2x cube minus x square y minus 2xy square plus 5 cube minus 4x square plus 8xy minus 4x plus 1 is equal to 0. Here see, the highest powers of x and y are 2x cube and y cube. The coefficients of these terms, that is coefficient of x cube is 2, coefficient of y cube is 1. So both of them are constants. So there are no asymptotes parallel to coordinate axis. Why? Because the coefficients of highest powers of x and y are constants. So this curve has oblique asymptotes. It is third degree polynomial. Hence it has 3 asymptotes. So let us consider them as y is equal to m1x plus c, y2 is equal to m2x plus c, y3 is equal to m3x plus c, and let us find out them by rewriting the given equation in the decreasing order of their degrees. So we have to write it in terms of h3 plus h2 plus h1 plus h0 is equal to 0, because third degree, so 3 terms we have taken, that is h3, h2 and h1 plus constant is equal to 0. That is x cube, that is y cube minus 2xy square minus x square y plus 2x cube. See, all these terms are containing third degree terms. See, a y cube 3 and 2x y square, x power is 1, y square means 2, So 2 plus 1, it is 3. So all these terms are third degree terms. So we group them together. Then going to the second degree terms, 4x square minus 8xy. So 4x square power is 2. Here x to the power of 1, y to the power of 1. 1 plus 1 is 2. So this term is second degree term. Then first degree only we have minus 4x and constant is plus 1. And now let us put y is equal to m and x is equal to 1 in this equation. So we get m cube, y is equal to m. So m cube minus 2xy square, 2 into 1 into m square, that is minus 2m square. X square y means it is 1 into m, that is minus m, plus 2 into 1 cube, 2. So the first term becomes m cube minus 2m square minus m plus 2. Similarly, the second term minus of 4 minus 8m minus 4 plus 1 is equal to 0. Now here phi 3 of m will be the first term of this equation, that is phi 3 of m is equal to m cube minus 2m square minus m plus 2, and second term, that is minus of 4 minus 8m, and third term phi 1 of m minus 4 and phi naught of m is equal to 1. Now the slopes of the asymptotes are given by phi 3 of m is equal to 0. So by equating this phi 3 to 0, so we get m cube minus 2m square minus m plus 2 is equal to 0. So this equation can be simplified by taking m square outside in the first two terms. So we get m square into m minus 2, and second terms, that is minus 1 if you remove outside, m minus 2 is equal to 0. See, among these two terms m minus 2 is common. So removing m minus 2 outside, we get m square minus 1 into m minus 2 is equal to 0. Now again expand m square minus 1 by using a square minus b square. So we get m plus 1 into m minus 1 into m minus 2 is equal to 0. Hence the roots are m is equal to 1, comma m is equal to minus 1, comma 2. See, all the three roots are distinct. So we have to find the asymptote for each root by using c is equal to minus of phi 2 of m is minus 4 plus 8m divided by phi 3 dash m means derivative of phi 3. Phi 3 of m is equal to m cube minus 2m square minus m plus 2. So by differentiating this, we get 3m square minus 4m minus 1. So that we have taken in the denominator, that is phi 3 of m is equal to 3m square minus 4m minus 1. Now put m is equal to 1, the first root in this equation. Then by substituting m is equal to minus 1, m is equal to 2, we get the values of c's. So first let us substitute m is equal to 1. So we get c is equal to minus of minus 4 plus 8 into 1, it is 8, by 3 minus 4 minus 1, which is nothing but minus 4 by minus 2, hence it is plus 2. C value is equal to 2. And similarly we will find out the values of the c for other two roots also. When m is equal to minus 1, this implies c is equal to minus of minus 4 minus 8 by 3 plus 4 minus 1. Substitute m value in this equation. We get 12 by 6, it is a plus 2. For m is equal to minus 1 also, we get c value plus 2. Then put m is equal to 2 in this equation. So we get c is equal to minus 12 by 3, it is minus 4. Hence the asymptotes are y is equal to m1x plus c, that is m1 is 1, so x plus 2 will be the first asymptote. Then second one, m value is minus 1, y is equal to minus x plus 2 is the second asymptote. Third one, m value is 2 here, c value is minus 4. So y is equal to 2x minus 4. These are the required asymptotes for the given curve. Then let us take up another problem. Find the asymptotes of the curve x cube plus 2x square y plus xy square minus x square minus xy plus 2 is equal to 0. Here the highest terms are x cube and y's highest term is y square. So highest power of x in this equation is x cube. Its coefficient is 1. It is a constant. Therefore, there is no asymptote parallel to x-axis. Then coming to the y-axis, the highest power of y is y square. Its coefficient is x. Hence, the asymptote parallel to y-axis is x is equal to 0. X is equal to 0 is the asymptote parallel to the y-axis. That's nothing but the y-axis itself. We got one parallel asymptote. The number of asymptotes to this curve will be 3 because it is a third degree polynomial. Already we have found one asymptote, x is equal to 0. So it will have 2 oblique asymptotes. So let us find out them by rewriting this equation as h3 plus h2 plus h1 plus h0. So by arranging the third degree terms of this equation, we get x cube plus 2x square y plus xy square as a first group minus the second degree terms, that is y square minus xy, and there is no first degree term, so the constant h0. h0 is 2. Now put x is equal to 1 and y is equal to m in this equation. So we get 1 plus 2m plus m square minus 1 minus m plus 2 is equal to 0. Here phi 3 of m is m square plus 2m plus 1 and phi 2 of m is minus 1 minus m and phi 1 of m is 0, phi 0 of m is 2. Now phi 3 of m, if we equate to 0, we can find the slopes of the asymptote. So the slopes of the asymptote are phi 3 of m is equal to 0. That means m square plus 2m plus 1 is equal to 0. It's a quadratic equation. So m plus 1 whole square is equal to 0. So we get the two roots m is equal to minus 1 and minus 1. In the previous problem, we had 3 distinct roots. So we found out to c by using the formula. But here we have repeated roots. So we have to make use of the second formula, that is c square by 2 phi 3 double derivative of m plus c into phi 2 derivative of m plus phi 1 of m is equal to 0. Now phi 3 double derivative is nothing but second order derivative of m square plus 2m plus 1. The first order derivative is 2m plus 2. So again if you differentiate, you will get 2. Hence phi 3 double derivative of m is equal to 2. By substituting that, we get c square by 2 into 2 plus c of phi 2 derivative of m. So phi 2 dash m means phi 2 of m is minus 1 minus m. So phi 2 dash of m will be minus 1. Substitute that here plus phi 1 of m. Phi 1 of m means the first degree terms 0. So take 0 here. Now by solving this equation, we get c square minus c is equal to 0. Remove c outside, then c into c minus 1 is equal to 0. By equating this to 0, we get c is equal to 0 and c minus 1 is equal to 0, which is nothing but c is equal to 1. So we have the two values, c is equal to 0 and c is equal to 1. Now the corresponding asymptotes are, the first asymptote is y is equal to minus x, and second asymptote c value is equal to 1, m value is equal to minus 1. So y is equal to minus x plus 1. Thus the asymptotes are, we have one parallel asymptote that is x is equal to 0 and 2 oblique asymptotes, y is equal to minus x and y is equal to minus x plus 1. Thus, the asymptotes of the given curve are x is equal to 0, x plus y is equal to 0 and x plus y minus 1 is equal to 0. Let us work out few problems on polar curves. Let us know the working rule to find the asymptotes of the polar curve. Step 1. Put the equation of the curve in the form 1 by r is equal to f of theta. So, you have to reduce the given equation to 1 by r is equal to f of theta. Then step 2. Solve for f of theta and let the values of theta be alpha 1, alpha 2, alpha 3. Then find out f dash of theta, that is the derivative of theta, and find the values at theta is equal to alpha 1, alpha 2, alpha 3 and so on. Step 4. The equation of the asymptote corresponding to the roots theta is equal to alpha 1, alpha 2, alpha 3 are given by r into sine of theta minus alpha 1 is equal to 1 by f dash of alpha 1, and for the second root r into sine of theta minus alpha 2 is equal to 1 by f dash of alpha 2, so on. So depending on the number of roots, we take the values. Note, if 1 by f dash of alpha 1 is infinite for any value of theta, then the curve has no asymptotes. If 1 by f dash of alpha 1 is infinite, then it will not have any asymptotes. Let us simplify a problem. Find the asymptote of the curve r theta is equal to a. So first let us write this in the form of 1 by r. 1 by r is equal to theta by a. Therefore, f of theta is equal to theta by a. Now solve for theta in this one. So that is f of theta is equal to 0. We'll put. So f of theta is equal to 0 means theta by a is equal to 0, which implies that theta is equal to 0. Therefore, alpha value is also equal to 0. So f dash of theta is equal to 1 by a. So f dash of alpha is equal to 1 by a. So the equation of the asymptote is r sine of theta minus alpha 1, which is equal to 1 by f dash of alpha 1. Now f dash of alpha 1 is equal to 1 by a. So by using that we get r sine of theta minus 0, because alpha 1 means the first value is 0, is equal to 1 by a's reciprocal is a, or it is nothing but sine theta is equal to a. Thank you.